So here we go, the next little group. We have a bunch of trig ones. Now this first one looks bad. It's got two different trig things in it, two different trig expressions. But if you look at your antiderivative trig list, secant tangent is straight on there. It's one of your, just one that you have listed. So it says the antiderivative of secant tangent is secant of x plus c. Okay, and that's all you have to do with that one. Your next one you see is cosecant squared. Now, let's talk about the 4 first. All you do with the 4 is bring it out. Now, if you look at your sheet, the antiderivative of cosecant squared is actually negative cotangent. So if you clean this one up, that's times, so that's negative 4 cotangent of x plus c. Okay, now we haven't seen theta very much, but this theta is just a variable, just like x is a variable. So this is understood to be theta to the 1. So let's do that piece by itself. So I increase 1 by 1, so 1 plus 1 is 2, over 2. And that would take care of the theta. And then you have secant squared. Well, if you look at your sheet, the integral of secant squared is tangent. You'll say, well, what happened to the square? It's a straight out rule on your sheet. The integral of secant squared is tangent. So it was just a straight substitute there. So we only have a couple left. Let's finish those up. Here we have this one. What you'll notice about it is you have one of the terms in the denominator, so we need to fix that. Now, in order to fix it and make it in a usable form, you're going to bring that 3 to the top, and then the sign changes. And now you're ready to take the derivative, antiderivative, sorry. So you're going to say that's 3 x to the 5th divided by 5 minus 5 x to the 3rd divided by 3 plus x, 1 plus 1 gives me 2 divided by 2 minus. Okay, so that's how we start. Add 1, add 1, add 1, that's what we're doing. Now this is where it gets a little tricky. I've got my negative x there, and I'm going to add 1. And I'm going to add 1 on the bottom. You'll say that wasn't so bad. So now we have to put it all together though. So we have 3x to the 5th over 5. That one's fine. 5x to the 3rd over 3. X to the 2nd over 2. Now here we go. Negative 3 plus 1 is a negative 2. Negative 3 plus 1 is a negative 2. In the bottom, you'd also have a negative 2. Now, let's clean that up. Okay, when we clean it up, of course, all we're cleaning up is the back piece. What you'll notice is you have two negatives, a negative here and a negative here. So that's going to give you a positive result. Two negatives make a positive. Now, what you'll also know is that that 2 is left in the bottom. You also see that you have an x to the negative 2 in the top. Well, an x to the negative 2 in the top is an x to the positive 2 in the bottom. There's nothing else left in the top, so you have a 1 there as a placeholder, and that is your final answer. And that's how that one would look. Okay, here's our last one. I can't work it the way that it looks, so I have to rewrite it. Remember that 4 is in the denominator, and that's how it would look. Okay, so your rule says I'm going to increase this by 1. 3/4 plus 1 over 3/4 plus 1. Now, we have a 1. That's understood to be 1 x to the 0. So you can actually use that it's 1 x to the 0 and then do your power rule there if you want to. Or you can remember, anytime you're taking the antiderivative of a constant, you just throw an x with it. Okay, so now all we have to do is simplify it. 3/4 plus 1 would be 3/4 plus 4/4, which is 7/4. So this would be x to the 7/4 over 7/4 plus x plus c. Now remember, the rule tells you when you're dividing by a fraction, that's like dividing by 7/4. That's the same thing as multiplying by the reciprocal. So we're going to say 4/7 x to the 7 over 4 plus x plus c. Now remember, you can always check these by taking the derivative of it.